The Space Shuttle program was a remarkable achievement in space exploration. It marked a new era where space travel became more accessible and routine. It was a game-changer, really. The program introduced a level of reusability that had never been seen before in space missions. For the first time, we had a reusable spacecraft. This innovation drastically reduced the cost of sending humans and cargo into space. This meant we could go to space, come back, and then go again. The shuttle could be refurbished and prepared for another mission, much like an airplane. Like catching a bus, but for space. This regularity and reliability opened up new opportunities for scientific research and international collaboration. The shuttle made space travel more affordable and sustainable. It allowed for frequent missions, which were essential for building and maintaining the International Space Station. It opened up a whole new world of possibilities for scientific research and exploration. Experiments conducted in the microgravity environment of space led to breakthroughs in various fields. The Space Shuttle program was a testament to human ingenuity. It demonstrated our ability to innovate and push the boundaries of what is possible. It showed what we can achieve when we put our minds to it. The program inspired countless individuals to pursue careers in science, technology, engineering, and mathematics. The program ran for 30 years, from 1981 to 2011. During this time, it became a symbol of human perseverance and ambition. During that time, 5 different space shuttles flew 135 missions. Each mission contributed to our understanding of space and our ability to operate in it. These missions achieved many things. They deployed satellites that improved global communications and weather forecasting. They helped us build the International Space Station. They deployed satellites. The ISS became a hub for international cooperation and scientific research. They even allowed us to repair the Hubble Space Telescope, which gave us incredible views of the universe. The Hubble has provided some of the most detailed images of distant galaxies and nebulae. The Space Shuttle program was a resounding success. It not only advanced our technological capabilities but also brought the world together in the pursuit of knowledge. It inspired a generation and laid the foundation for future space exploration endeavors. The legacy of the Space Shuttle program continues to influence modern space missions and inspire new generations of explorers. The Space Shuttle was a complex machine, a marvel of modern engineering and a testament to human ingenuity. It was designed to be reusable, unlike the single-use rockets that came before it, making space travel more economical and sustainable. It had 3 main parts: the orbiter, the external tank, and the solid rocket boosters. Each of these components played a crucial role in the shuttle's mission, working together seamlessly to achieve the goal of space exploration. The solid rocket boosters were the 2 white rockets strapped to the sides of the external tank. They provided most of the thrust needed for liftoff, burning for about 2 minutes before being jettisoned and falling into the ocean to be recovered and reused. The orbiter looked like an airplane, but it was so much more. It was the part of the shuttle that went into space and came back to Earth, capable of withstanding the intense heat of re-entry and landing like a glider on a runway. It was the part of the shuttle that went into space and came back to Earth. The orbiter was equipped with heat-resistant tiles to protect it during re-entry, ensuring the safety of the crew and the integrity of the mission. The orbiter housed the crew and the payload. The crew cabin was where astronauts lived and worked during their mission, while the payload bay carried the cargo, which could include satellites, scientific instruments, or even parts for the International Space Station. The payload was whatever the shuttle was carrying to space, like satellites or parts for the space station. These payloads were crucial for advancing our understanding of space and improving life on Earth through satellite technology. The external tank was the big orange thing attached to the belly of the orbiter. It was the largest component of the shuttle and was filled with liquid hydrogen and liquid oxygen, which served as fuel for the shuttle's 3 main engines. It was filled with fuel for the shuttle's 3 main engines. These engines would ignite at liftoff, drawing fuel from the external tank to propel the shuttle into orbit. Once the fuel was depleted, the tank was jettisoned and burned up upon re-entry into the Earth's atmosphere. The solid rocket boosters were the 2 white rockets strapped to the sides of the external tank. They provided most of the thrust for liftoff, working in tandem with the main engines to lift the shuttle off the ground and into space. They provided most of the thrust for liftoff. After their fuel was spent, they were jettisoned and parachuted into the ocean, where they were recovered, refurbished, and reused for future missions. Think of it like this: the orbiter was the bus, the vehicle that carried the crew and cargo to space. It was designed to be reusable, making it a cost-effective solution for space travel. The external tank was the fuel tank, providing the necessary propellant for the journey. Without it, the shuttle wouldn't have the power to reach orbit, and the solid rocket boosters were the extra engines that helped the bus get moving. They gave the shuttle the initial push it needed to break free from Earth's gravity. Together, these three parts made up the mighty space shuttle. Each component was essential, and their combined efforts made space exploration possible, paving the way for future missions and discoveries. Launching a space shuttle was a complex and dangerous operation. It took months of preparation. Before every launch, engineers and technicians would painstakingly inspect every inch of the shuttle. They made sure everything was in tip-top condition. The fuel tanks were filled, the payload was secured, and the crew went through their final checks. On launch day, excitement filled the air. The countdown would begin. The world watched as the clock ticked down. At T-0, the solid rocket boosters ignited with a deafening roar. The ground shook, and a giant plume of smoke and fire erupted from the launch pad. The shuttle slowly began its ascent, picking up speed as it climbed higher and higher into the sky. The launch was just the beginning of the journey. The shuttle had to reach an altitude of over 100 kilometers to escape Earth's gravity and enter orbit. The solid rocket boosters burned for about 2 minutes. Then they separated from the external tank and parachuted back to Earth. The orbiter's 3 main engines continued to fire, propelling the shuttle faster and faster. The ride was bumpy. The astronauts inside experienced intense G-forces, but they were well trained and prepared for the physical demands of spaceflight. About 8.5 minutes after liftoff, the main engines shut down. The shuttle was now in orbit, traveling at a speed of over 28,000 kilometers per hour. That's like flying from Singapore to London in about 15 minutes. Section 5. Living and working in space. Once in orbit, the crew got to work. They conducted experiments, deployed satellites, and even helped build the International Space Station. Living and working in space was, well, a unique experience. There was no gravity, so everything floated. Astronauts had to adapt to doing everyday tasks in a weightless environment. They ate specially prepared food, exercised regularly to maintain their muscle mass, and slept in sleeping bags strapped to the walls. The shuttle had a life support system that provided oxygen, removed carbon dioxide, and regulated temperature and humidity. It was like a mini Earth in space. Section 6. A fiery return. After completing its mission, which could last for several days or even weeks, the shuttle prepared for its return to Earth. The crew would meticulously check all systems, ensuring everything was in perfect working order. This phase was crucial, as any malfunction could spell disaster during the re-entry process. Re-entry was the most dangerous part of the mission. The shuttle had to withstand extreme temperatures and forces as it plummeted back to Earth. The crew inside would feel the intense vibrations and G-forces, a stark contrast to the weightlessness of space. The shuttle had to re-enter the Earth's atmosphere at a precise angle. This angle was critical, too steep or too shallow, and the consequences could be catastrophic. If it came in too steep, it would burn up. The heat generated would be too much for even the shuttle's advanced heat-resistant tiles to handle. If it came in too shallow, it would bounce off the atmosphere and be lost in space. This would mean drifting endlessly, with no hope of returning home. As the shuttle slammed into the atmosphere at over 25 times the speed of sound, friction caused the air around it to heat up to thousands of degrees. This intense heat would create a fiery spectacle visible from the ground. The shuttle was covered in special heat-resistant tiles to protect it from the extreme temperatures. These tiles were a marvel of engineering, designed to withstand the searing heat and protect the spacecraft and its crew. The shuttle slowed down rapidly during re-entry. This deceleration was necessary to ensure a safe landing, but it also added to the stress on the vehicle and its occupants. It went from being a spacecraft to a glider. This transition was seamless, allowing the shuttle to glide smoothly towards its landing site, completing its fiery return to Earth. Section 7. Shaping the future of spaceflight. The Space Shuttle program had a profound impact on the future of spaceflight. It showed that reusable spacecraft were possible. This paved the way for the development of modern reusable rockets, like SpaceX's Falcon 9 and Blue Origin's New Shepard. These rockets are making space travel more affordable and accessible than ever before. The Space Shuttle program also demonstrated the importance of international collaboration in space exploration. The International Space Station, which was assembled with the help of space shuttles, is a testament to what we can achieve when nations work together towards a common goal. The legacy of the Space Shuttle program lives on. It continues to inspire scientists, engineers, and dreamers around the world. Section 8. A legacy of scientific discovery. The Space Shuttle program wasn't just about engineering marvels and feats of human daring. It also made significant contributions to scientific research. The shuttle carried numerous scientific payloads into space. These payloads conducted experiments in a variety of fields, including astronomy, biology, and materials science. The Hubble Space Telescope, which has revolutionized our understanding of the universe, was deployed and later repaired by Space Shuttle missions. The Chandra X-ray Observatory, another powerful space telescope, was also launched by the shuttle. The data collected by these telescopes has helped us unravel the mysteries of the cosmos. Section 9. Conclusion: the enduring spirit of exploration. The Space Shuttle program may have ended, but the spirit of exploration that fueled it lives on. The shuttle showed us that anything is possible if we dare to dream big and work together. It inspired a generation of scientists, engineers, and astronauts. It showed us that humanity's reach extends beyond the confines of our planet. The Space Shuttle program may be over, but the journey has just begun. We are standing on the shoulders of giants. We are continuing to push the boundaries of space exploration, driven by the same spirit of discovery that propelled the Space Shuttle into the heavens. The future of space exploration is bright, and it's up to us to write the next chapter in this incredible human adventure.